Okay, so this is the last part of probability. It's the multiple events. Once y'all have finished this homework, you're going to submit it underneath the multiple events, and then tomorrow I'm just going to go over both the probability and the probability of multiple events questions that y'all might have had on the homework. Okay, so get all that submitted in. So we looked at both and or. Okay, so within the or problems, we can have what's called mutually exclusive and not mutually exclusive. Okay? So I like to refer to this as, I don't know, dating, because that's what it means to be exclusive with someone, right? Theoretically, when you are exclusive, do you date other people?
I would hope
No. Theoretically. You know that doesn't happen all the time, okay? So when you are exclusive with someone, you are only dating that one person, okay? So with mutually exclusive events and not mutually exclusive events, as weird as it sounds, when you look at the two events, you're going to say, can they happen at the same time? If you answer yes, then they are not mutually exclusive. Okay? So that's weird. This is always a bad segue when I'm talking about dating, and then I'm like, yes means no, and no means yes. bad intro into that. But with mutually exclusive, when they are mutually exclusive, the two events cannot happen at the same time. Just like you can't date two people. Okay? And this top one is you're not mutually exclusive. I'm going to put not me. All right? And that is when two events can happen at the same time. All right, so the good news is the two formulas that are given to you help you with that. Notice how they both have the probability of A plus the probability of B. If the event can happen at the same time, then you'll subtract away the probability of them happening at the same time. Okay? So for example, I can ask you the question, to roll a number cube, rolling an odd number or an even number. Can that happen at the same time? No, you can't have an odd and an even number at the same time. Okay? So it cannot happen at the same time, so then that would be mutually exclusive. Okay? And we would just find the probability of A plus probability B, we call it an A. Okay? But if I ask you the question, the probability of rolling a 2 or an even number, can that happen at the same time? Yeah, 2 and an even number, that's the same thing, okay? So you would find the probability of getting a 2, probability of getting an even number, and then you take away the probability of an even number and 2 happening at the same time, which would be the same as the first one, but in that particular case. All right, so you first ask yourself the question, can they happen at the same time? You say yes, they're not mutually exclusive. If you say no, then yes, they are mutually exclusive. And then the formula pretty much does the rest for you, okay? All right. So, more times than not, you won't have a cute little visual next to it, but read through the example first. But I got those mixed up. I wrote that down over here. I think I did. Yeah. Okay. So first thing you ask yourself, can you have an ace card that is also a face card? No. Okay. The ace does not have a face. All right. It is literally just the symbol that's on there. That's why I showed y'all that deck of cards. So since it cannot happen at the same time, then yes, it is mutually exclusive. Okay. So then now what we do is follow that formula. So the probability of the first event, so the probability that we get an ace is what?
113.
Do it. Oh, you reduced it. So give me the basic one first.
452.
4 over 52. Just for note's sake. Okay. And then the probability, why is it not changing colors? Weird. There it is. Okay. And then the probability that it's a face card. What's that? Okay. 12 out of 52. So we get 16 out of 52. And that is about a 31% chance of that happening. Okay. Now, some of y'all might leave 4 over 13 as your answer, and some of y'all might have 31% as your answer. Okay. I will not be picky unless I am asking specifically for something in the question, okay? On my answer key when I'm grading y'all's homework, I actually have both written down. So that way I can easily grade those, okay? So I just first ask the question, can they happen at the same time? If they can, it's not mutually exclusive. If they can't, it is mutually exclusive. We follow the formula, okay? Try this one. Okay, so I asked myself the question, can it be a heart and the face card at the same time? Yeah, okay. So we're first going to look at the probability that it is a heart card, okay? So again, you've got this visual up here, but without this visual, you would have to know that information on your own. So how many heart cards do we have? 13. Okay. Plus the probability that it's a face card. So how many face cards do we have? 12. Okay. Then, since it can happen at the same time, we have to subtract the probability of it being a face card and a heart. And what's that? 3 out of 52. Okay, subtract all of that together. And whether you give me the fraction of 11 over 26 or you give me 42%, I'll accept both. Notice how I'm not accepting if you gave me 22 over 52. Okay, if you're going to give me a fraction, I want it to be completely reduced. Okay. Any questions so far? Yeah.
Do you want us to always just round to the nearest whole number for the percentages?
If I tell you otherwise, I mean, it's funny because I get those questions a lot, and then I do specify on a question, and then y'all don't do it. Like I'll say round to the nearest tenth, and y'all give me 5 decimal places.
Yeah.
But it'll specify if I want it to be something special. But yes, I have been rounding them all up. Love these questions. Already a percentage. Go ahead and read through that. Here comes the discussions in regards to if I ask the question, is it possible to live in Dallas and Denver or Denver?
Well, you wouldn't be alive. You're in both of them.
Well, how many people?
You can have a house in Dallas.
Right, that's what I was gonna say. How many people know somebody, or you are that person that has a house somewhere and a house somewhere else? Okay. Some of my very rich friends have multiple houses.
Private island.
I
Who
am
does?
Bill Gates.
Congratulations.
Thank you. I'm also.
Just remember that when you want to make
it.
it. I know yesterday was
A
Giving
generous
Tuesday, but
donation
if you want to make a donation to your teacher's fund, that's fine too.
Well, I mean, I asked you if you needed, paper towels and stuff. I believe you said no, so I think.
Originally, yes, I did ask for paper towels, but we're at a shortage right now, so
This
that's
is why we've
we're.
been keeping it a
rationing.
secret for a little while because lots of people ask him for stuff. and
He's my financial advisor, so he usually
Gotcha.
that stuff away.
I always say that every year. I'm like, when y'all like go off to be something great and make a lot of money, don't forget about your teacher. And I've been teaching for 12 years.
Well,
and I
see,
still
we're-
haven't gotten a check back.
We're more likely to remember you if you name your kid DJ in honor. So there's a give and take.
I did have a friend that said if I named our kid a combination of their names, that they would pay for its college, and I was not afraid to do it because I was like, "Hey, college."
Make it like their
Me and
middle
Jonah will
name.
pay
Make
for
it his
the
middle
college.
name or something.
Oh no, it was like
I
the
will
first
spend all
and
my
middle
inheritance.
all together. But
Love you.
so yeah, so people could have an argument about this and say, well, technically I could if I really wanted to live in Dallas or Denver, okay? But this is just strictly saying one place where I can live. So no, these cannot happen at the same time. So since they cannot happen at the same time, they're mutually exclusive. And since they're already giving us the probability, you're literally just going to add the two percentages together.
Yeah.
And you get an 83% chance that they're going to live in Dallas or Denver. That's why I said I love these problems. So straightforward, add them together, call it a day.
I wonder what the other 17% is.
Anywhere else? North
Alaska.
Dakota.
I would be pissed if I got a managerial position and they moved me to freaking North Dakota.
Idaho.
They said Nebraska. They send you straight.
I always forget about it.
Okay, try this one.
I don't think anybody even
The people in Nebraska are like, where do I live?
What's wrong with Nebraska?
kind of answered the question yourself. It's Nebraska. Bless you.
So have we determined if it can be a female and a sky blue parakeet at the same time? Yeah. So it's not mutually exclusive. All right, boys?
No.
Okay. So what is the probability that it is a female?
Uh,
42.
42.
Out of 79 total. Okay. Probability that it's a sky blue parakeet?
44 over 7.
Okay, and then a female sky blue parakeet.
8 over 7.
Okay, if we reduce that, we should get 58 over 79, or in other words, 73%. 73% chance. Okay, any questions on that one? I've seen on this one also where people have drawn a chart. If that helps you too visually, you can do that. It's going to give you the same information that you're getting just by looking at it, but it helps that you get to do something a little bit more visual. Okay. So the next one is nice only because the visual is there for you. If the visual was not there for you, it'd make things very difficult. And what I mean by that is you would have to write out all the possible outcomes. So since the visual is there,
Yeah, it is.
you don't have to create all the different types of scenarios where it says 2 6-sided dice. So this is when they're specific. They're saying you're rolling 2 of them. They're both 6-sided, okay? There are 36 possible outcomes as shown. Find the probability of each given event. So sometimes the question becomes, well, are they going to be picky about it being 1 and 2 and then 2 and 1, okay? So then that becomes a discussion. Or do we flip-flop them, all right? But yes, we've got 36 outcomes here. Go ahead and figure out both A and B. Like I said, it helps when the visual's there, and when it's not, that's when we run into issues.
How to process.
Maybe you want to create your own visual on your paper instead of looking up there and counting. Walk through, sorry guys. Probably a lot easier for the virtual kids because the computer screen's right up against them and they're able to go. If they're still listening, of course.
Hi, Caden.
Hi, Maddie.
You know they're not listening.
We love you. We think about you.
That's neat.
What was that about mutually exclusive?
Yeah, I know, right? What did we learn about today? Not dating 2 people at the same time.
That's called a polyamorous relationship. You ever heard of a throuple before?
What? Whoa.
My friend, I haven't seen her.
No, it's a few.
It's a few.
Let's not.
It's not one. You brought it up.
Naturally, it would be my fault.
Really,
God, don't wrap me into this,
Really
Daniel.
pointing fingers. You know, just saying. I was told this morning actually by one of your virtual students that I'm a celebrity because they hear all the stuff that me and Jonah say in the recordings. And that they
You're
enjoy
a
it.
celebrity.
Yeah, so really, I think we're enhancing the learning experience.
I think
The
that,
learning
yeah, more people watch, like, I feel like, not to be mean or anything, but more people watch because of some of the stuff that we say, because, I think that we're helping your viewers.
Oh,
Yeah, you
okay.
get the ratings you do because of it.
Oh,
They were calling us poggers.
wow.
Oh.
Wow.
We love you, Miss Chapman.
Uh-huh.
You.
Uh-huh.
You are great.
You know, I'm very thankful that I have y'all to enhance the learning for other people.
Well, thank you. We're glad that you can give us the opportunity.
Do I?
Once.
Yes. Kind of.
Okay.
You said to record our class period. So.
Yeah, because there's like 5 people in 7 a.m. And I also teach faster after I've taught it once. I'm like, oh, we've done this before. All right, so the sum is not 8. What's my probability? Well, let me get I have the fractions, but let me get my decimals or my percentages in case y'all say those. Okay. What is the probability that the sum is not 8? Who has that one? 31 over 36, okay? Or an 86% chance, okay? Okay. Probability that the sum is greater than or equal to 4. Okay, what you got?
91%.
I got 92 only because the 6 rounds up to 1. But yes. So did you get 33 over 36?
Yes.
So 33 over 36 to get 92%. So it'd be a lot easier if you had this literally in front of you and like the first question you said the sum is not 8. I could go through and cross things out that are not 8 and count them up. Okay. So that would be a lot nicer if I had that available to me, or I could cross out the ones that do equal 8 and save me a little bit less crossing things out, unless that's what you're in the mood for. Okay. But, would I probably draw a dice every single time if I was drawing this on my own? No, I'd probably just go 1 and 1, then the 1 and 2, 1 and 3, and then keep going like that as well. Okay. So if you need that visual representation, make it for yourself. Okay. So any questions on probability and multiple events happening so far? Okay. All we have left to learn is conditional probability.